Hi everyone, welcome to the Software Engineering Lecture Series. Before diving into the technical concepts, it is important to understand how this course is structured. In this video, I will walk you through three key areas: course guide, what this course covers and its objective; weekly lecture plan, how the topics are distributed over the semester; and the third is assessment of CLOs, course learning outcome, how your progress will be evaluated. By the end of this session, you will have a clear roadmap of what to expect and how to succeed in this course. So stay tuned and let's get started. Course summary. This course covers the full software development life cycle, including process model, development methodology, requirement management, design, project planning, testing and software quality. Student will explore emerging trends of dev apps and gain hands-on experience through the project in some modeling, design pattern, testing, vision control and CI/CD pipelines. These are the textbooks which was already uploaded in the Google Classroom, and these are reference books, and there is no prereq for this course. Graduate attributes. Academic education is GA1. Equipped graduates with comprehensive knowledge to become skilled computing professionals. Second is knowledge for solving computer problems. GA2 applies computing fundamental specialized knowledge and relevant sciences to model and solve computing problems. And the third one is problem analysis. G3 develop the ability to identify and formulate and solve computing problems with using mathematical and computing principles. These are CLOs, course learning outcomes. CLO 1 is about understanding STL model, standard and process. Domain is 3-2 and you need to understand this one, and Bloom taxonomy level is 1 and match with the graduate GA1. The second is describe the test cases and bug reports for different project sizes, C2, and it is also understand, and then you have a GA2. CLO3 is about apply object oriented design principles and pattern for the scalable softwares, and it is apply C3 and GA3. And the fourth one is analyze software requirements using UML model, and it is C4, and it is analyze GA3. Graduate attributes are 3. So course outline with the week breakdown. Week 1, the course covers the nature, definitions and domain of the software, including legacy systems, engineering practice, common myths. It also introduces the software development life cycle, models such as waterfall, prototype and spiral. And we will, in the activity, we will explore a good software, compare open versus closed, and we also have a R&D cover with the agile speak to agile methodology, key artifacts, principle, scrum, extreme programming, and the different methodologies, and rapid development in a part 1 of activities. And then we have a feature driven development, comparison of feature driven development, FDD, and test driven development, TDD, in software engineering, and impact of pair programming, this one, evaluating whether use pair programming compromise to enhance the software quality. Week 3 and 4, requirement engineering, covers functional and non-functional requirements requirement analysis and change management. Identify the functional, non-functional and domain specific requirements from a given scenarios. And then we have software engineering process, which is based on JAD, Joint Application Development, software modeling, context model, structures, behavioral model, use case model, sequence diagram, activity diagram, class model, etc. And then we create a context diagram for level 1 and level 2 based on the given case study, and class diagram with the entity diagram relationship in terms of structures and application. Week 5 and week 6. In week 5 we have architecture design, key software design principles including modularization and the concept of coupling and cohesion. An architecture pattern, overview of architecture pattern holding with a layered architecture, repository architecture and client server architecture. For scalable and maintenance of software design, analysis of problem element to identify the key system models, ensuring modularity with low coupling and high cohesion of an efficient design. Then we have a project management and estimation, understanding the management spectrum, people, product, process, project, defining project scope, creating a work breakdown structures, WBS, and applying a procedure diagram. And then we have a method PDM from this one, activity for effective project planning and estimation, identify for your semester or final year project, and create a work breakdown structures, WBS, to break down the project into smaller manageable components. Then use the procedure diagram method and to visually represent the sequence and dependency between tasks. Software project estimation, decomposition and estimation, empirical estimation, LOC line of codes and function FP, functional points based estimation methods and leveraging model like COCOMO and Putnam resource allocation models, and resource allocation for project resources and cost for costing. Week 7 and week 8, project risk management, identifying software risk, implementing reactive and proactive strategies, risk projection, refinement and impact assessment. And identify potential FYP proposed methods and mitigate the impacts. Software quality assurance, key element of SQA, quality attributes, process-based quality, SQA task, goals, quality metrics, quality standards, product versus process, and SQA planning. And then for the activity, we have the analysis, a case study to identify essential quality attributes, metrics, and standard, and develop a basic SQA plan with defined task and goals. Week 9 and week 10, we have a software testing, introduction of software testing, its objectives and verification versus validation, criteria of complete testings, and the software testing process models. It covers black box, white box, gray box testing strategies, testing level, and automated and manual testing. And then we have a comparison of black, white box and gray box strategies. And then another software testings, week 10, we have a black box testing methods, graph-based testing, boundaries, value analysis, and equivalence of class partitioning. Flow diagram testing, independent of white box testing, independent program path, condition, loop testing, test case, and then we select a case study to implement black and white box techniques. Week 11 and week 12. Week 11 we have a software seminar. We will try to invite some our repute faculty members to discuss a few points. And then another point is software process improvement, key factor affecting software product process, attribution and challenges, improvement cycle, SPI process, and CMM and CMMI process area in this one. And then activities based key key factors affecting software products and attributes in final year projects. Then we have a software configuration management system in which we have a SCM features and SCM terminology. And then we discuss, identify and explain to key elements, terminology, feature of configuration, and quick group discussion. So remember this one, we have a group discussion in week 12. And we will discuss SM process in application is web developments and the concept of version and release management. Exploring emerging trend in software engineering, focusing on DevOps, its methodology, principle, strategy for continuous delivery, and the cloud computing. Explore the integration of machine learning and AI in software engineering with the focus on use of NLP, open source framework for equivalent processing. This one is grade policy in which assignments and 4+4 30%, midterm 25 and final 45, and we will have a total this one. Assessment of CLOs and these assessment quiz 1, quiz 2 and quiz 3 based on CLO 1, 3 to 4, and same have assignments 1, 2, 3, 4. Midterm only CLO 1 and 2, and final term we have a 2, 3, 4. And these are the taxonomy levels. You can see there are 2 labeled 3, 3, and one is C2, 4 and C4. And similarly, the graduate attribute is 3, 3 and 2 and 4. No makeup quiz assignments, no late assignments will be accepted. All assignment projects submit with the course of individual work only. So we don't have any group work. So we have an individual work. Group work is explicitly prohibited. Remember this one, no group work. Severe penalty if we found anything violation of the rules. An F grade will be allocated if project assignment are found copied from the internet or any other resources. Thank you.